on graphically. We found limits to the graph. Now we're going to look at it algebraically. And to do that, we're going to use the limit properties. So before we go through those, everybody can either get their property sheet out or turn to page 35 of your textbook if you don't have it. Okay, so now, when we look at a jump, just a quick recap. A jump discontinuity. That is saying that you approach one number and another number, making it discontinuous. So that was saying if you had one limit and you came to one point or another, where you had to jump from one part of the function to the other part of the function. So mainly, when you have a jump, it's in a piecewise function. We have an infinite discontinuity. What the infinite discontinuity is saying is the function, if you're looking at a particular spot, so if there's an asymptote here at 2, and you're looking from the left, if you come from the left, where are you going? You're going down to negative infinity. So you do not approach something. You're approaching negative infinity or infinity, and that is an infinite discontinuity. A removable discontinuity. What is that? A removable discontinuity, if you remember back to advanced functions, if you have it, remember how we got a hole? What happened when we had a hole? Okay, the denominator and the numerator would cancel out. Here's a case where you had to remove something. It is a removable discontinuity because something you had to rearrange. So what will happen in a removable continuity question is, we'll talk about this, but you'll do a direct substitution, and then you will get this, which is called an indeterminate form. So it will look like 0 over 0, infinity over infinity, and so you'll have to do further steps in order to continue with the limit. And this is more the algebraic type question. So we can actually write this as the square root of the limit as x goes to negative 4 of the stuff inside. The square root's still there, but the limits can apply inside the square root. That's the power property.
Do we have to know all the properties?
Continue on. There's another property of addition and subtraction. And it says that if you are adding two things, that you can take the limit of each of those as well. So this is the same thing as saying, still the square root of the limit as x goes to negative 4 of 2x plus the limit as x goes to negative 4 of 5. And that's based on the addition-subtraction property. So the next part, if we look at this limit here with the 2x, 2 is a constant. What did we say the limit of any constant will always be? It's going to be the constant. So we can bring that 2 out front, and then we still have the limit as x goes to negative 4 of x plus, and then we could technically solve this, but we'll just leave it and do it till the end. Would be your square root of 2, we know that's negative 4, and we know the limit of any constant will be the constant, so we still have plus 5. We continue on and we solve. We have the square root of negative 8 plus 5, and we have the square root of negative 3. Ruh-roh. What happens? Can we do that? No. So does the limit exist? No. So therefore, the limit does not exist. Questions about that? And we have to go. The limit of x going to 1 of x, all squared, minus the limit as x goes to 1 of 10 over the limit of x goes to 1 of x squared plus the limit x goes to 1 of 5. So, as the limit as x goes to 1 of x, what will it be? Perfect. And that's based on the second one on your sheet or your textbook. Minus the limit of 1 as it goes to 10. 10 can only go there. Pardon me?
It's called direct substitution.
This is direct substitution. That's right, we're subbing in. So then 1 squared plus 5, 1 minus 10 over 1 plus 5, negative 9 over 6, or negative 3 over 2. That's right, we have a limit. The limit exists at negative negative 3 over 2. So you see this is a little bit nicer because when we're doing it graphically, you'd have to come from the right, come from the left, figure out what value it's approaching, make sure they equal, and that's what the limit would exist at. Here you can do it algebraically and you have the exact value. Over. So let's do that direct substitution. I'm just going to write ds so we know. And if we plug that in, we have 1 squared minus 6 times 1 plus 5 over 1 squared minus 3 times 1 plus 2. And what does that equal? Ruh-roh. The strategy that you wanted to pick would be factoring. So let's do that. Okay, so let's factor the top. I'll add a page. So we have the limit as x goes to 1 of, because this a value is 1, we can do a super fast factor. We don't have to do decomp, we don't have to do quadratic, although you could, you don't have to. You want to look for two numbers that multiply to get 5 and add to get negative 6. What are those? And we know our first two variables have to be x and x to get the x squared term. What will the denominator be? Perfect. And what do we see? We can cancel. Yay. So once you cross it off, go back to the beginning. Direct substitution. If we do a direct substitution and we put it in, 1 minus 5 over 1 minus 2. So we have negative 4 over negative 1 equals 4. So therefore, the limit exists at 4. What do we think we do with this? And we got, and what's this called again? Remember? This is an indeterminate form. I forgot to mention it with the other one. So when you have 0 over 0 or infinity over infinity, it's an indeterminate form. So that's our denominator. And if we multiply the numerators together, yeah? So if we multiply the first, we have two basically binomials. They're not polynomials, they're all numbers. But if we multiply the first times the first here, what will we have left from that? All you have left is 4 plus x. But if you multiply these two together, and then you multiply these two together, are they the exact same thing with the opposite operation? So they cancel each other out. So then all you have left is this last term times this last term, which is? So if we look at after the subtraction of the 4's, we can cancel again. We have an x in the numerator and an x in the denominator. Just be careful. You can look at it that there is a 1 in front, so if you cancel, you're still left with, and let me do that in a different color actually. You're still left with 1 in the numerator. So you have the limit as x goes to 0 of 1 over square root of 4 plus x plus 2. And then we go back to the beginning. What do? Direct substitution. Step number 1. The limit exists at 1 over 4.